Okay, those at home, can you give me a like if you're in? Have you woken up? Can you give me a like if you're in? I should have 2 likes. Okay? Now the notes will be posted on the same SLS package at the end of the day. Right, let's start our lesson. From the first part, we have already proven, right? So let's add in what we have proven, 1 plus cos theta, d theta. Please integrate. Okay? Right? Term by term integration. First one, Janice. From what we have integrated is this, right? So let's recall from the previous part. What we have integrated is, what we have proven is, what have we proven, by the way? What we have proven is sine theta over cosecant theta minus cotangent theta is equals to 1 plus cos theta. This is what we have proven, right? So, okay, did I make any mistake? If I have, please point it out. Yes, Daniel? Sorry? I know. Besides this, what else did I miss? Yes, Chunhao? Chunyong or Chunhao? Correct. There is a 2 here, right? There is a 2 here. In this expression, there is a 2, but what I have taken is without the 2. So to make it proportionate, what should I do? If I multiply by 2 here, I must multiply on the right-hand side. So this should be 2 here. This is the critical part for this entire question that very often our students miss out. Okay? So if I would integrate this with respect to theta, what would it be? The first term, Audrey? Theta plus next term, Jeannie? Integrate cosine gives me sine plus c, where c is a constant. If you don't like this format, you find it very confusing. What you can do is, this is another way of presenting it. You can actually bring the 2 in if it's going to help you. If you find that this way is going to help you, you can go ahead and use this. And in the SLS March holiday homework, adding constants is what the quiz is about, right? So that is the difficult part of this chapter. Okay? So this is simply 2 theta plus 2 sine theta plus c. Okay? So that is practice now 10. Let's move on to practice now 11. You still need this? Practice now 11. The dy dx part. Let's have somebody to show. Any volunteers? How many of you have not done it? Let's be honest. 2 minutes. Can you do it now? If not, later speed stop, you will evaporate. We have 2 minutes. Let's try practice now 11. I deliberately sifted out all these practice now because these are the ones that the students usually have more difficulties in. When you see ln, ask yourself, how should you integrate when you see ln? Can I integrate it straight? Can't, right? Because it will be very complex. If I was to integrate it straight, it's very complex, okay? So I must always apply what? Log. So log is ln 7 minus ln root 8, 6x plus 1. Ln 7 minus power log. This will make your integration much simpler. Sorry, your differentiation much simpler. Okay? Hope this helps in the 2 minutes. Okay? Shafiq, can you differentiate this, please? Differentiate. This is constant, so it disappears, right? How do you differentiate? So what does it become? F prime over fx, right? Then you simplify, this is simply negative 3 over 6x plus 1. How many of you got this? Give me a thumbs up, please. Okay, I think it's not easy when you can even remember applying the log law. Now, let's do the second part. Integrate 9 over 7 dx. Okay? Before we go to that, what is the relationship between dy dx? So let's come back to this. When I integrate this thing, this expression, what will I have? If I were to integrate this, what will I have? Credit? What should I have when I integrate my dy dx? I should have gotten back my what? Sorry? Are you serious? If I integrate this, what will I have? Logically, if I integrate this, I should get back the original y, right? Right? So I should get back this. Plus c, right? Where c is a constant. So this is the blue statement. This statement, the blue statement, should be what is floating in your mind to help you construct this. Okay, so what is floating in your mind is the blue one. So you may want to write in pencil. Okay, so this is what is going in my mind. Okay, I integrate the dy dx, I should get back my y. But now I get this expression. It is not my, it doesn't look like my expression here. So this constant here is bugging me. This constant here is bugging me. I'm going to factorize it out. So if I take out 9 over 7, okay, I will get this. This is bugging me, right? Okay, I take out 9 over 7, it's bugging me. So I must ask myself, okay, this is not what I'm seeing. What I must be seeing is negative 3 over this. There is no negative 3. So if I were to make this a negative 3, I am changing the equation. Am I right? So what should I do? That's right, I should multiply it by 1 over -3. So that I do not change my equation. Okay? So that's the thinking behind. So with that, you may want to write it in blue on your own. So what is 9 over 7 multiplied by 1 over -3? What is it? Multiply by 1 over 3. Then this one I multiply by -3. Yeah? So what does it become? -3 over 7. -3 over 6x plus 1. That is how your friend is able to visualize the constant that is being changed. And that is the difficult part. And this, from my thought, the blue thought in there should be ln the original. Okay? Then you can put here where C is a constant. Right? So the difficult part is not the differentiation. The difficult part is the constant to incorporate. Right, so this is practice now. 11. 12. You have 5 minutes. Please try it on your own. 12. Practice now 12. Later you will have 5 sums like that. Okay, for the students at home, if you are doing this, you also do the pit stop. At the end of this period, please upload the pit stop. I need an error. I took out 9 over 7, right? There should be no negative sign here, am I right? Okay, so that's why the negative sign stays outside. Please discuss and buzz to confirm your thoughts for yourself. Practice now 12 is the same constant that you're going to add. You want the answer is in the textbook, right? How you like this part? This one is definitely going to be an O-level question. The spirit of it, huh? Okay. Any volunteers for the differentiation before I pick my royal guest? Differentiation first, Let's get G. Okay. Skipping up. Where's G? Excellent. What? I don't need it. Isn't you? Come. Style your hair first. Anyway, they have no makeup. They'll watch the yellow. See? Then after that, I let you pick another person to do the hands integrate. I'm coming around to check for examples 12 and 13 completion. You have not done better doing. Yes. One. And I think your legacy will stay in SLS. Is that the nicest you can write? The product rule formula, it seems a long time ago. Raise the ydx, dvdx, correct? Bring up power, reduce the term by one. The next person that he picks, product rule. Product rule. State the product rule and then substitute it. Hence, integrate part. Let's have shall we? Hence, integrate part. Shall we? Share. Come. They can't see you, they can see black. Okay, question 2. I'm walking around. Those paper empty one, get ready. Yeah. Partial fractions for practice now 13. There are 3 types, right? What are the 3 types? Is that all, my friend? That's all. You are asked to integrate that. Why don't you give us your bubble based on that statement? Can you use the blue marker? Write down your bubble. That means integrate what gives you what based on the y equals to dy dx. Can you check your product rule first? Let's settle that. Okay. Now, another thing I want you to think about is, why do you think Practice Now 12 gives you a show where they know you can obviously do it yourself? Why did they ask you to show? Why? for me? Now, I know that your brain and your psyche will be thinking, hey, I can't do the hands integrate part. So I don't care whether you can or cannot do. I just need you to show me this in pencil in your homework. So that I know you know what is the relationship between differentiation and integration. This part, are we all okay? Yeah? So you must tell yourself, okay, I'm going to integrate this. I will get back my y. This is the expression they gave me. Right? It doesn't look quite like this one. Do we agree? It doesn't look like it at all. So they are actually waiting for you to show them. The relationship of how you connect the one that they ask you to differentiate to integrate. So what they want is they want you to show them this. Definitely not equal, right? Not equal at all. So what is the constant you put in front? Sorry? That is the critical part, and they're going to give you a mark for that. So hard. That's why she introduced a constant here. So they won't give you the M1, A1, no? This is M1. They will not give you the A because you have not shown the relationship. Okay? So, then you tell us, okay, I'm going to integrate this. Give me this expression, so it gives me back this original. Where C is a constant. Now, why do you think they ask you to show and not ask you to find dy dx? Why do you think they help you? They're helping you. Why do you think they're helping you? Sorry? No, the marks is the same. But it really makes a difference between find dy dx and show dy dx. Why? That's right, you know. So that you know that you know how to apply this part that they have given you to solve this. So if the paper is a kind paper, they will ask you to show. So even you make mistakes, you know where you make the error. The tougher papers will ask you to find, and you have no guidance. So this paper is kind. The way the question is set is kind because they don't penalize you twice. You can't differentiate, just use the what they have. Okay, next. So the crux for homework, I want to see this. I'm not interested in you turning to the answer key and copying the answer for me. I'm beyond that. Okay? I want to see how you connect your thought with what is given. Question 2, Danish. 2, differentiation part. Danish, pick your partner for integration part. Oh, get to picture. Danish, choose your partner for the idea. Come, Xavier. Let me. Quotient rule. Partial fractions, how many of you have done it? Get ready? I want to know the 3 general type of partial fractions, how you change it. So you use it as a formula book with you now. Lesson is ending 10:45, is it? So you won't have time to do the what? We will end with practice now, page 15. Practice now 13 partial fractions is the last one. The last one, you can do it on your own. Okay, I will put the solutions on SLS. I repeat, I will stop at page 15. Practice now 13. The rest of it, I'll put it in SLS, the solution. Okay? Lydia, can you put the thought in the blue bubble? Put your thought. Connect the differentiation and integration. Can I have the forms for partial fractions? Give me the first one. I'm going to get people to recap partial fractions. How you link, integrate what gives you back what. Jermaine is writing the first type for partial fractions. I want the categories of partial fractions, the different forms. Pass the marker on, Jermaine, to anybody else. So the first case is linear vectors. So you can split the partial fractions up like that. The next type. Okay. Are you okay with the solutions? Right? Okay, huh? Let's do the last one, partial fractions. We'll use the visualizer for this one, and I'll take a picture of your work and post it on MOU. SLS. Any volunteers? We'll put in the partial fractions type. Ready? Practice now 13. Let's have Evangeline. What's the marker on? So this one, the second part that Tassino put for partial fractions is the repeated factors. Last category. Focus, please. No, not Zivi again. Pass it to somebody else. Okay. How many of you get the partial fractions that Evangeline showed? Raise your hand. Right. How many of you did the integration part? Hand remain raised. Jeannie will show her solutions on the screen afterwards. On the screen, on a visualizer. Take a picture of that. How many of you got the solution that Jeannie showed? Not too bad, right? For 6 marks. Okay. Now for partial fractions, are these the 3 categories? Are these the 3 categories? Linear, linear, repeated linear, and non-factorizable. Are these the 3? So please recap. Right? Now I will cut off the live stream now. The rest of the things can be attained via the SLS. Bye.